Hello, welcome to helpyourmath.com. In this video, we're going to discuss compound interest. In question number 5, we are now going to look at various definitions for the given compounding periods. So we want to fill in the periods per year in each column because this is going to become important in our questions in the future, and has been too. So annually, when we say something is annual, we mean 1 year, or n is equal to 1 from our formula in the previous video. Semi-annually would mean n is equal to 2. Quarterly means that n is equal to 4. Monthly means n is equal to 12. Weekly means n is equal to 52. Daily is 360. And finally, hourly, if we calculate it out, is 8,760 hours in a year. So this would be the n in our formula, which is the periods per year. The reason why in our previous video we didn't get into that because we were talking about everything annually, so we didn't have to worry about this as much. Let's go back to the compound interest formula we looked at in the first video and look at it again. So, as before, we had the starting value x bracket 1 plus the rate to the number of repeated multiplications, that would be the power. So the accumulated amount is equal to P bracket 1 plus R over N, close bracket, NT. But now we understand what N is. And N is the number of times that it is compounded per year. Usually in the first video, we had N is equal to 1. And if we have 1 here, we usually don't write it. But if we're going to have multiple compounding periods, we have to explicitly state what N is. So to review, A is the accumulated amount, P is our principal or starting amount, R is the rate or the annual rate, N is the compounding period, and T is the time in years. To repeat again, the most important thing to remember about this formula is that it assumes we put money in the account once and let it sit there earning interest. In question number 6, we're asked, how does the compounding period affect the accumulated balance? Well, we would find that the more compounding periods we have, the higher the accumulated amount. A certificate of deposit, CD, is a savings instrument that many banks offer. It usually gives a higher interest rate, but you cannot access your investment for a specified length of time. Suppose you deposit $3,000 in a CD paying 6% interest compounded monthly. How much will you have in the account after 20 years? So let us go over to the whiteboard and work this out in detail using our formula for compound interest. In this problem, or this question, where we have where we purchase a CD that's $3,000. That's going to be our principal. And we know when we purchased it that we're going to earn 6% interest per year. And it's compounded monthly. So we're going to use our formula. A is equal to P, which is our principal, 1 plus rate over the number of times compounded in the year times the number of times compounded in a year times the time we have the CD. So we have our principal, as mentioned here, is equal to $3,000. So I'll just rewrite that P is equal to $3,000. Our rate is equal to 6% per year, but we have to convert that into a decimal, so that's 0.006. And since it's compounded monthly and there are 12 months in the year, that means over each year, there are going to be 12 compounding periods. Our time that we keep it as a CD is 20 years. So we want to calculate this. A is equal to 3,000. 1 plus rate 0.06 divided by N, our compounding period 12. And here we have 12 and then times 20 for the 20 years. So I'll multiply this and I'll get $3,000, 1 plus, and that's going to be 0.0. No, well, I should do the other thing first, but I'll do this inside here. 0.05, and I'll multiply 20 times 12, and I'll get 240. So we now we want to add those up inside the bracket. So that's going to be equal to $3,000, 1.005 to the 240 power. Now, when I put this in my calculator, 1.005 to the 240, I get a long number. So I want to just keep that number in as long as I can in my calculator. So what I got was 3.3102, and I'll ... however many numbers your calculator does. And now I'll multiply into my calculator the 3,000, and I will get $9,930.61. And that would be my final answer. So after 20 years, my $3,000 investment has become $9,930.61. In reviewing what we did on the whiteboard, we found or know that our principal is $3,000. That's the initial deposit. Our rate is a 6% annual rate, so that we convert that to decimal 0.06. Our N is 12 months because of 12 months in 1 year. Our T is 20 years since we are looking for how much we will have in 20 years. And then we took this information and we plugged it into our formula. And we found after we worked out in detail on our calculator the formula, we got $9,930.61. Rounding review. It is important to be very careful about rounding when calculating things with exponents. In general, you want to keep as many decimals during the calculation as you can. Be sure to keep at least 3 significant digits, numbers after any leading zeros. For example, rounding 0.00012345 to 0.000123 will usually give you close enough answer, but the more digits you keep, the better during the calculation. It's only at the end that you want to round it to, let's say, the nearest cent or the nearest dollar, and that you would only do at the very, very end of your calculation. In question number 8, we're asked to compare the amount of money earned from compounding against the amount you would earn from simple interest of $3,000 deposit in question number 7. So let us work this out, at least the first line for the first 5 years in detail on the whiteboard. In question number 8, we're asked to compare the amount of money earned from compound interest against the amount of money you would earn from simple interest of the $3,000 deposited in question number 7. So in this particular question, we'll look at simple interest first. Simple interest. Now, we are told that we will get 6% interest per year. We assume this is paid monthly, and what this means is that we have 6%, and this implies per year. And this means that if we're going to look at what we get monthly, that would be 6% per year, 1 year, times 1 year has 12 months. And this means that each month we will have an interest of 0.5% per month. Now, interest, which here is simple interest, is principal times rate times time. Now our principal is the $3,000 that we deposited. The rate we found was 0.5% per month. But we have to convert that into our decimal. So that's going to be 0.005 per month. Per month. And our time here is going to be equal to 1 month. Since we're going to be getting our interest monthly. So our interest will be 3,000. So our interest finally will be our $3,000. That's our principal. Our rate, which is 0.005 per month. And then times 1 month. We'll just put 1 month. So that means that we will get, so times 1, which the time is 1 month, so we don't have to write this. So that means we get $15 per month. Interest. So, or $15. So if we cancel that, we can just get our interest is $15 over that period of time. And our period of time is really 1 month. Okay? So now we're doing this for 5 years. So again, we use our simple interest accumulated amount. P is equal to A is equal to principal plus interest. And in this case, since we're now going back to years, we have the $3,000 plus our $15 per month that we just found per month. Times 12 months in 1 year. Times 5 years. So we multiply all that out and we cancel out the months and the months and the years and the years. And we end up with our accumulated amount is $3,000 plus $900, meaning in 5 years, that's how much we have. And we will end up having in our account $3,900 after 5 years. Now we will look at our calculation, or we will find for compound interest. So for compound interest, we will use our formula. A is equal to P, 1 plus R over N to the power NT. And now, remember, our principal was equal to $3,000. Our rate was 6%, 0.06. Our N is 12 months because it's compounded monthly. And our time is 5 years. So I plug in my numbers into my formula. A is equal to $3,000 times 1 plus 0.06 divided by 12 to the power of 5 times 12. And then we start calculating that on our calculator. A is equal to $3,000 times 1 plus 0.005 to the 60th power. And then we add that inside the bracket to get 3,000 times 1.005 to the 60th power. And then we plug that into our calculator to get $3,000 times, note that we're only powering the 1.005, and we take that to the 60th power to get this whole long number, meaning it's long after the decimal point. So we write as many decimals as we can, or we just keep it in the calculator. In this case, we can just keep it in the calculator. So we multiply whatever we get here by 3,000 in order to get 4,046, $46.55. So that's our final amount that we get when we compound our money. So we found for simple interest, we have our $3,000 plus the $15 that we earn per month in simple interest times 12 months per year times 5 years, and we got $3,900. We found the accumulated amount when we used compound interest, and we plugged it into our formula, 3,000 bracket 1 plus 0.06 over 12 to the power of 5 times 12 gave us $4,450. $46.55. So let us continue the same process through 10 years. So we have $3,000 plus $15 times 20 months per year times 10 years now. And that'll give us $4,800. Now we do the same thing using compounding. And we find that we'll get $5,400.58, $5,458.19. In 15 years, simple interest, we'll get $5,700. If we do the same thing, but we compound it during that time, we'll get $7,362.28. For 20 years now, simple interest will get $6,600. If we do the same thing compounding, we'll get $9,930.61. After 25 years, simple interest will get $7,500. And compounding over the same period will get $13,394.91. 30 years, simple, $8,400. 30 years compounding, $18,067.73. 35 simple, $9,300. And compounding, $24,370.65. Wow, what a difference compounding makes as compared to doing things simple interest. So you make so much more when you compound than if you do something with simple interest. In question number 9, you need to know that you will need $40,000 for your child's education in 18 years. If your account earns 4% compounded quarterly, how much will you need to deposit now to reach your goal? So let us go over to the whiteboard and work this out in detail. In question number 9, we know we will need $40,000 for your child's education in 18 years, or you will need. If your account earns 4% compounded quarterly, how much will you need to deposit now to reach your goal? So in this question, we are looking for P. Which is our principal. So we have our rate, 4%, and that becomes 0.04. We know our time is in 18 years. We know that N is going to be compounded quarterly, which means 4. Quarterly means it's going to be compounded 4 times over the course of a year. And we know that we want an accumulated balance at the end of this 18 years of $40,000. So we will use our formula. A is equal to our principal times 1 plus rate over number of times compounded in the year times number of times compounded in the year times the time. So that's going to give us, we're going to put our numbers in, 40,000 is equal to our principal, but this we don't know. 1 plus 0.04 over 4. And it's to the power of 4 times 18. So that's going to give us, so we're going to work this part out in here in the power. So we get, and just add it up like we did before. So we're going to get 40,000 is equal to P 1.01 to the 72nd power. So that's going to be equal. Now we want to do a little bit of algebra. So we're going to do our power, take care of that. And that's going to be equal to P principal times 2 point, and we're going to get a long decimal thing, 4, 7, 0, 9, 9, ... Now, my calculator can't hold that. It doesn't have a memory part. So I'm going to take as many numbers as I can there. And I have on this side 40,000. So I'm going to divide both sides by 2.047099. And I'm going to divide this side by 2.04799. And so this cancels out. So I end up with P. So I end up with $19,539.85. Or 84, depending on how your calculator calculates, and that would be our principal, meaning how much we would have to put into this account to get the $40,000 that we need in 18 years. So remember, this may depend a little bit on your calculator rounding. So it could be 80, 84 or 85 cents, give or take a few cents. In reviewing what we did on the whiteboard, we showed that we're looking for P, which is the principal. Our rate is 4%, and we converted that into a decimal. Our N, meaning the number of times it's compounded during a year, is 4 for quarterly. Our time is 18, since we know the balance in 18 years. We want to know, since we know the balance in 18 years. And A, the accumulated amount, is the amount we will have in 18 years. So this is what we were looking for. So in this case, we set up the equation to solve for P. So here I did it here. $40,000 is equal to P0, meaning what we'll need to deposit now, our principal. 1 plus 0.04 over 4 for 4 quarters, and we have that 18 times 4 power. And we found when we worked out this part, we got 2.0471. And then we took the 2.0471 and we divided it by 40,000, and we ended up with $19,539.84. So you would need to deposit $19,539.84 now to have $40,000 in 18 years. Thank you for watching this video. I hope that you enjoyed it. Be well and goodbye for now.